This is a kind of a two-dimensional work question. So it tells us that a 100 Newton applied force at an angle of 40 degrees to the horizon is being applied onto the handle of a wagon. The wagon is 150 kilometers. It moves for 10 meters, and we're looking for the work done. So what's really important to remember about this question is that the only work I particularly care about is the work that is in the same direction of motion. So if I have just a really quick free body diagram here, my applied force looks something like this, where it's coming off at 40 degrees. Well, I'm not going to use the entire 100 Newton of applied force. I'm only going to use the component that is in the same direction of my movement. So my motion is this way for 10 meters. So I'm just looking for what I would typically define as the x component. So our x component is going to be adjacent, so it's sine or cosine. Sorry. So the force applied that I really care about for this question, so we can say FA x, for example, is FA cos theta. So that's 100 newtons times the cosine of 40. So that leaves us with an actual useful force in terms of work of 77 newtons. It's in the forward direction because, of course, it's in the same direction of motion. So then we can quickly wrap up this problem by saying that work is equal to your force. In this case, it's the AX times your displacement. So 77 newtons times 10 meters, which is going to leave us with 770 joules of work.